Glass and heat. Since the beginning of times, people have sheltered from cold and bad weather, like today, in caves, igloos, built of snow, structures made of clay and reeds, bamboo or wood and straw. These primitive dwellings were heated by the warmth emitted by human bodies or by the first fires. Later, people realized that openings in the walls, passing sunlight, helped to warm interior spaces, provided that wind did not blow through and the rain did not pour in. With the invention of the first glass, this problem was solved. Glass allowed light to pass through while protecting against the elements. Glass, as part of windows and doors, evolved and became one of the key elements of modern residential and commercial buildings. Short introduction. What is heat? And how is it transferred? And how is it transmitted? Heat is transferred from a warmer element to a cooler one. Heat transmits in three different ways. Conduction. Direct heat transfer, when molecules of one substance interacting with molecules of another transfer part of their energy to them, causing those molecules to heat up. Convection, when warm, less dense, lighter gases rise upward. Thermal radiation, the transfer of energy in various ranges of electromagnetic waves, for example, infrared, which causes substances or bodies to heat up. Perfect example, when you sit by the fire and you feel that warmth even without touching the fire. Originally, glass was single layer, imperfect, with bubbles and uneven surface. On cold nights, heat escaped through such windows by conduction. During the day, however, short-wave solar radiation entered. Objects and bodies inside were heated and re-radiated this energy, warming up the space. In the 19th century, humanity learned to manufacture flat glass by floating it on molten tin. The result was transparent, smooth, perfectly flat glass. A useful side effect of this production process was the appearance of so-called K-glass, where molecules of tin diffused into the glass surface capable of retaining infrared thermal radiation. Homes became warmer. Later, the number of glass layers was increased, improving resistance to heat transfer. Thanks to the air gap in the glass, the air is an excellent thermal insulator. The process of heat transfer from one surface to another took much longer, helping to retain heat within the controlled volume. It should be noted, however, that over time, indoor and outdoor temperatures will inevitably equalize if no heat is supplied in any way. Just a question of time. Example, place the most highly insulated thermos beyond the Arctic Circle during the polar night, and over time, without heating, the temperature inside and outside will equalize. With the development of technology, humanity has developed ways to deposit metal atoms onto surfaces, which acted like mirrors, reflecting infrared radiation and selectively interacting with different wavelengths of the electromagnetic spectrum. Thus, in late 70s, a product called heat mirror appeared, developed by Southwell Technologies. I had the opportunity to become closely familiar with this product during my years working with at Four Seasons Solar Product and SkyTech. This product was widely used there in multiple applications. This coating was applied to a synthetic film positioned in the center of insulated glass unit. The product had many limitations and problems. The assembly process and product operation were challenging. The unit had to be assembled with polyurethane sealant in the heat chamber and treated for a long time. Exposed to ultraviolet radiation, polyurethane disintegrates and allowing moisture to get inside of the glass. Moisture reacting with atoms of metal creates visual imperfection. The next step in evolution of glass was the position of multi-layer selective coatings directly on the glass itself. And we distinct soft-coated and hard-coated coatings. The hard-coated can be tempered. There are companies such as Arcon Glass, which specialize in creating of varieties of different coatings, selective, tuned up to any client's needs. However, for the most part, there are like 5 world manufacturers of the glass, and their product lines are basically similar. The main parameters of these coatings are U value, solar heat gain coefficient, visible light transmission, and visible light reflection. It actually marked on every glass, and as I said, there are many similar products. Today, by using multi-layer thermally insulated glass with a variety of high-performance coatings, it is possible to achieve unique results and literally build houses made of glass that are capable of withstanding any weather. However, we must not forget one very important point. Without a supply of heat, over time, the temperature outside and inside will inevitably equalize.